Welcome to another iCampSA video. So we're doing Doppler Effect questions today. Okay, let's get on. So here, the question says a learner in a car moving at a constant speed of 10 meters per second along a straight horizontal road records a frequency of sound emitted by a distant stationary source, right? So we're just going to keep note of the important things as we go. Then the learner then repeats the recording of frequency of sound when the car travels at a new constant speed of 20 meters per second. Okay. Then they say the graph below, not drawn to scale, is obtained from the results. Right. So we can see that from here, the y-axis, we can see recorded frequency in hertz. And then here we can see the speed of the car. Okay. So the first question says state Doppler effect. So I've already written it down. Please revise it, but use your exam guidelines for it. So here the Doppler effect says the change in frequency of sound detected by the listener, because the listener and the source of sound have different velocities relative to the medium of sound propagation, right? So it's as simple. Okay. So then we go to the next question saying use the graph to answer the following questions. So now we've got 6.2.1. So they're saying here, write down the frequency of sound emitted by the stationary source, right? Okay, so we just need to go to the graph. So we can see that at this point, the car was already moving, right? And this is the frequency when the car was moving. But now, this is the frequency when there was no movement, okay? So that means that is the original frequency that is emitted by the source, because both of these objects, or the listener and the source, were not moving at this point, okay? So that would be your 700 hertz, okay? Now your reasoning would be, because this is the point where both of these two were not moving, okay? This is when they were stationary. Okay, now 6.2.2. So 6.2.2, they're asking us in which direction is the car moving relative to the source, right? So we can see that, okay, so if we are saying this is the frequency that is emitted by the source, we can see that when the car starts moving, the velocity here is increasing, but the frequency is decreasing. So for the fact that the frequency is decreasing, it means that the car is moving away, right? Because if you're moving towards the car, then the frequency would increase because you'd hear more noise, okay? But now if you're moving away from the source, it means you're going to hear less and less sound. So that means the frequency is going to decrease. So that means here you are moving away, right? And why is that? Because the frequency is decreasing. Okay, that is as simple as you can put it, right? And then the last question here is asking us 6.2.3. So the last question is asking us calculate the speed of sound in air. Okay, the speed of sound in air. So now let's see how we calculate it. Right, first of all, what we need to do here is let's go get our formula for the Doppler effect. So that would be to calculate the frequencies. Okay, so now here we can say frequency of the listener is equals to, this is the velocity of sound plus minus velocity of the listener all over v again, and then velocity of the source, and then frequency of the source, right? So from there, we've already got the frequency of the source here. So we can just go back a bit. We said that the frequency of the source is equals to 700 hertz, right? That's what we said. And then now what's going to happen, because we're looking for the velocity. So now, depending on which frequency of the listeners we're going to use, and then we're going to use the speeds accordingly also. So now if you're taking this one, that means you're going to take 20 here. Okay, that's what we're going to do. But now if you use this one, then you're going to use 10 meters per second, because that's how it goes. So we can use, let's use maybe the first one, for instance. At this point, we're going to use the 10 meters per second one. So that means FL, so FL is going to be 679.1 hertz, right? And then V, we know that V here is 10 meters per second. Okay, so now we are almost there, right? So what we must remember is that we said that Vs is stationary, so that means it's going to be 0 meters per second. Okay, so this is VL, sorry. So that means what we're going to do here, we are going to look for V, right? Just V. So now we must remember, so what were the conditions of this? Okay, because when we come here, we're gonna say FL is equals to V. Now this is gonna be plus or minus VL all over V. Now the source is 0, is plus or minus 0 here. Okay, so that means what you're gonna end up with is V plus or minus VL all over V. Okay, so now we are left with a job of actually finding out, is this going to be negative or positive? Okay, but now we have said that the listener is moving away. So if the listener is moving away, that means we are going to have a negative here. So that means we end up with V minus VL and then over V, then Fs here. Sorry. Right? So now it's just a matter of substituting into our equation, and then we can get our answer. Let's see. Okay, so here we've got FL is equals to, right, now let's remember, let's just get our numbers so that it's easy for us to substitute. Okay, yeah, right, so now we've got all of the data. It's a matter of now substituting here, and then we get the answer that we're looking for. So that means for our FL here, what we're gonna have is 679.1 is equals to V is what we are looking for minus 10 meters per second, because this is the velocity of the listener. Then all over, what do we have here? We're going to have V again, and then all times 700. Okay, then we can then work around this to see what we get. Okay, so now this is pretty much simple to do. You can just let me just do it like so. Okay, so you can have 679.1. Okay, like so, and then you're going to have 700 V minus 700 times 10. Okay, so now once you've got something like this, it's pretty much easy. You can punch your calculator and see what we get. So what's going to happen is that you're going to have, let's change a bit of color. So we have 679.1 being a V, is V, equals to 700 V minus 7,000, like so, right? So we can take this one to the other side and then take the other to the other side, right? So what we're going to have is 7,000, right, like so. Then 700 V minus 679.1 V, right? So now we can do that difference and see what we get. Okay, from my calculator, I get something like so. That is going to be 20.9 V. So we can just divide by 20.9, 20.9, right? Then we're going to end up with our velocity. So what do we have from our calculator? Because this goes away, and then we punch in calculator. And then therefore what I'm getting here from my calculator is 334.9 meters per second. So that's actually it. So what you can do here, you can test with the other method and see what you're getting from there, and then but then the answer should be the same. Okay, cool, guys, that's it. Thanks, bye.